use of pesticides in agricultural production has long been thought of as a necessary evil, needed to sustain our global food demand. Even when you buy organic, that doesn't necessarily mean that you are eating pesticide-free, and most consumers don't know that. However, the biggest tragedy comes when we're speaking about the workers, especially the migrant workers who are handling these produce every day. They are exposed to such high levels of pesticide that it can cause tragic symptoms such as seizures and/or death. Therefore, we are developing a device called agrospheres, meant to degrade the residual pesticides on produce before you harvest them, improving the working conditions for these migrant workers and improving our health outcomes.
Now we're here to walk you through the magic behind our technology. Amir, can you tell us how it works?
So we're using mini cells to degrade pesticides. What is a mini cell? A mini cell is essentially an empty vesicle, and we put on it a pesticide degrading enzyme. The mini cell has about a lifespan of about 1 to 2 weeks. It is non-toxic and does not contaminate the environment. After these 1 to 2 weeks of its degrading pesticides, it disintegrates and essentially disappears from the environment. Hi, could you tell us how we made these mini cells?
Sure thing, Amir. Now, in normal bacterial division, the septic ring forms perfectly in the middle to form two identical bacterial cells. As you can see, there's bacterial cells, the desired enzymes, but in our case, we induce the formation of a mini cell after we introduce a plasmid. And what happens is the septic ring instead forms at the end, at the polar end, and this results in asymmetrical division. So you have one bigger, elongated bacterial cell with multiple DNA strands and an empty, tiny mini cell. But since the mini cell comes from the bacterial cell, it still expresses the enzymes on the surface membrane. And that's how the magic works. Hey guys, this is the first step of our protocol in producing agrospheres, and it's the transformation step. So this is a step where we need to introduce our DNA into regular bacterial cells to make them produce mini cells. So what we do is we take bacterial cells out of the -80 fridge, let them slowly come to life on the ice, and then we put the plasmid in, let it sit for about 30 minutes, and then once the plasmid's in, we heat shock our bacteria. We take it and put it in 42 degrees Celsius water for about 45 seconds. And in this step, the membrane of the bacterial cells expands, and any near DNA around it will be taken in. And then once the heat shock is over, we put it back on ice and let the membrane compact, and hopefully the DNA is now within the cell. And then you add some media and put it in the incubator and let the bacteria cook. And that's the transformation phase.
Now that the cells have been transformed, it is time to plate them and to check which cells have been successfully transformed. I will take a 100 microliter sample. Drop it onto this agar plate. And then to ensure that we get colonies that are far apart, I will spread the sample. And if the plating step is successful, we incubate overnight, and if it is successful, we get colonies that look like this.
Alright, so now that we have our mini cells, we need to separate them from their parent E. coli strain. And we do that by using a syringe and a filter. So what I will do is take this sample, put it into the syringe, once we have a certain amount, within now you can compare samples. Contaminated with bacteria, just mini cells.
So once you have your purified mini cell solution, you can put them in a spray bottle, spray it onto your plants, wait a few hours for them to degrade all the pesticides, and in a week your mini cells will disappear, and that's the beauty of agrospheres.
I am happy to be part of agrospheres, the future of agriculture.